In my last video, we defined the imaginary unit I. In this video, we're going to discuss what we mean when we say a complex number. Okay, what we mean a complex number is. Okay, so we say complex number. You think about it, it should mean something that is necessarily complex. So we say complex numbers in standard form. A complex number written in standard form is a number a plus bi, where a and b are the real number parts, and we have the imaginary unit I in here. So what I can tell us is simply this. We say anything that is a complex number is kind of like this. If you were to draw a sketch, and this is a good sketch to kind of consider. We say if this were the set of all complex numbers, we'd have the real numbers right here, and we'd have imaginaries over here, the set of all imaginary numbers with the imaginary unit I. So we'd say imaginary numbers have units I on them. We say like the bi or something like that, some number times I. And then the real numbers are just like purely real numbers, like a number a. But we say real numbers are they don't ever overlap with imaginaries. If it's real, it's not imaginary. If it's imaginary, it's not real. But what happens when we start to add, say, a real number a plus an imaginary number I, or bi? We say, well, then this forms what we refer to as a complex number. Okay, so a complex number is really just the sum of a real number and an imaginary number. So this a plus bi here, let's make a few notes on this. We say a, we refer to a here as the real part of the complex number. If a complex number is the sum of a real and an imaginary number, we say the a part is the real part. We refer to the bi part. This is the imaginary part. Okay, so this is the imaginary part of our complex number. But a complex number is nothing more than an imaginary and a real number glued together. So I make a few notes here. We say the number a is the real part of the complex number. The number bi is the imaginary part. But I say if b doesn't equal 0, if this is true, then a plus bi is an imaginary number. And actually what I think that I mean to say here is if b doesn't equal 0 and a does equal 0, we say it's a purely imaginary, or it's an imaginary number here. Actually, no, I make this note down here, I apologize. We say if b doesn't equal 0, then we say this is an imaginary number. But if a does equal 0 and b doesn't equal 0, then a plus bi is purely imaginary number. So what I want to basically point out is this. Given a number a plus bi, let's say that this part right here, the a part, is not 0, and the b part is 0. Then we would get a number like this, 4 plus 0i, which would equal 4. We refer to anything that has a b part being 0, but the a part not being 0, as just a purely real number. This is purely real because it has no imaginary part. If we were to have a number now, a plus bi, where the b part, this part is not 0, but the a part is 0. Then we would have a number such that it would be like 0 plus 4i. Something like this, for example, which would equal just 4i. And we would refer to this as a purely imaginary number. Okay. If it has both an a and a b part, then we say it's just a complex number. All of these are complex numbers. But a complex number in standard form can be written in a plus bi form. So these two numbers here and here are both complex numbers. It's just that they're also, in these instances, purely real and purely imaginary, respectively. Okay, so complex numbers would be any number that has a real part and an imaginary part. We say 3 plus 2i would be a complex number. 4 minus i, that would be a complex number. We could even say 0 plus 3i is complex, just as much as 3 plus 4i would be complex, or 3 plus 0i. Any number that you've already dealt with in your life, you've dealt with complex numbers. You just didn't know that you were dealing with them. So any of these numbers are complex numbers and can be written in standard form, that is a plus bi form. Okay. So part of this video I want to get across is what a complex number is. It's the sum of a real number and a complex number together. And so all numbers that we've ever dealt with here, even the purely imaginary and purely real ones, can be rewritten as a complex number in standard form. So all numbers we've ever dealt with are complex numbers. Okay. We can also graph these complex numbers. So just as we can graph a point xy in the xy coordinate plane, we're going to refer to this XY looking thing down here is the complex number plane. Okay, so the complex number plane looks a little bit different, works a little bit different. We refer to the vertical axis as the imaginary axis. So we're going to call this right here, this is our imaginary axis. Imaginary. Oops. Axis. And we're going to refer to what we formerly called the x-axis as the real axis. The thing here is this. We say we can graph numbers, actually graph a number in a complex number in standard form by knowing two parts of it. We say A is the real part and B is the imaginary part. Then what we'll do is if we say the real axis is our real part, then we say this really corresponds to the A part of our complex number. Since formerly the y-axis refers to the imaginary axis in the complex number plane, it refers to the B part. Here, the B part. So we'd say this would be like B. But essentially, all of these numbers on the left here, we're just going to graph them very, very quickly and show you how this works. But all we need to know is what's the real part, what's the imaginary part. We can actually graph the number in the complex number plane. So we say in this first example here, we say 2 plus 3i. We see that A is the real part and B is the imaginary part. We have an A value of 2 and a B value of 3. What this means is from the origin here, we will go right 2 and up 3. In other words, we would say this is our first point over here. We'll label this point A. Okay, I know it's redundant. I shouldn't be using A and B for anything other than real and imaginary parts, but we say this first point right here, point A, is this point over 2 up 3. The reason why is because it has 2 for a real part and 3 for an imaginary part, and those things meet up here at 2, 3. Okay, moving forward, we could keep running with this idea. We say, well, how would I graph this number here, -3 plus 2i? Well, we'd say, well, then our A value is -3. Our B value is +2. So on our real axis, we'll go left 3. On our imaginary axis, we'll go up 2. We say this is our point B. Okay. So you'll notice on the next 3 examples here, we're dealing with, in this instance, something that is purely imaginary, so purely imag, and something here on letter D here that is purely real. How does one graph a purely imaginary number? And the thing I would implore us to do is this: rewrite the number as a complex number in standard form. So if I said 4i, how would I write that in A plus bi form? That'd be the same thing as 0 plus 4i. And so what we can see here is that our A part is 0 and our B part is 4, which means we're going to go left and right none, and we're also going to go up 4. So what I want us to recognize is when you graph a purely imaginary number, it occurs on this imaginary axis. Okay, it doesn't deviate left or right because there were no parts to it that were real. Likewise, when we say -5, well, -5 written in standard form is the same thing as -5 plus 0i, where we have an A value of 5, negative, and a B value of 0. So a purely real number, if a purely imaginary occurs on the imaginary axis, a purely real number occurs on the purely real axis. So we'd say left 5, 1, 2, 3, 4, 5. Okay, draw a dot. We go up and down none, which is our D, point D. But we'd say it's a purely real number because it occurred on the axis. And then last but not least, we say 0. Where would 0 be at in the complex number plane? Well, this is the same thing as 0 reals plus 0 imaginaries. So we'd say this would be the origin. So the number 0 corresponds to the origin in the complex number plane. So just to recap, complex numbers are the sum of real numbers and imaginary numbers, and it's sometimes true that you have purely real or purely imaginary numbers, but they're still complex numbers and can be written as a complex number in standard form, just as 3 could be written as 3 plus 0i, or in 3i could be written as 0 plus 3i. Also we can graph these points. We refer to the x-axis as the real axis and the y-axis as the imaginary axis. But if you know the real and the imaginary part, you can make your way to the number by deviating that far left or right, up and down, respectively, depending upon what your real value was and your imaginary value was. Cheers.